an investment type of problem. So in this case, Danny invested some money into 3% simple interest. That's a poorly worded first sentence, but that's okay. And some money at 7% simple interest. The amount invested at a higher rate, so the higher rate was the 7%. The invested at the higher rate was $3,000 more than the amount invested at the lower rate. If the total interest on the investment for 1 year was $810, then how much did he invest at every rate or at each rate? So in this situation, again, you can choose whatever X value you want. You can either say that X is the amount invested at 3% or the amount invested at 7%. This one, it really doesn't matter. So I'm just going to go with the first, let X equal the amount invested at 3%, not 30%, 3%. Okay, so other stuff that we have here. I know that I have a total. This is my total. So as I set up my equation, 810 is going to be to the right-hand side. Totals are always going to be on that right-hand side. As we break it up, we have two situations. We're taking the 3% and adding it to the interest of the 7%. So I know that we're going to have a plus sign here. So how we kind of break this up? We know that we have a 3% simple interest account. So what I'm going to do is I'm going to take 0.03 and write it there. We also have a 7% interest account. So we have 0.07. What gets tricky is the stuff that goes with it. The nice thing is, in the first step, we said that X was the amount invested at 3%. So that's my X. How we take this 3,000 more at the higher rate. So whatever I invested at the lower rate, the X, I invested 3,000 more at the higher rate. If you would have flip-flopped your let statement and said that X was the amount invested at 7%, this would have been X minus 3,000, and this would have been an X. So it works the same way. You just would have to adjust and say, okay, well, it's got to be 3,000 less than if you would have said let X be the amount invested at 7%. We didn't do that, so I'm going to erase it. That's my equation. From here, it's the same strategy that we've used consistently. We are going to take, or haven't I used? There we go. We're going to take that 0.07 and distribute. So this becomes 0.03x plus 0.07x plus 210 equals 810. Combining like terms, so combining those together and also subtracting that 210 over, we have 0.10x equals 600. Dividing by that 0.10 or 0.1, we end up with X equals 6,000. So the amount invested at the 3%, the lower rate was 6,000. If he invested 3,000 more at the higher rate, I would just add 3,000 to my X value. So how I'm going to communicate this is 6,000 was invested at a rate of 3%. And 9,000 was invested at a rate of 7%. And the reason I did that in different colors, I do want to talk briefly about how I'm getting that. All I would be doing is taking that 3,000 or that 6,000 and plug it in there in parentheses. You're not plugging it into the whole equation unless you want to verify that that would give you $810, but you are just plugging it into the 3,000 more than. Most of you won't do that because in your head you can add 3,000 to 6,000. But I do want to at least mention that before we move on. So again, how we would check this is take 6,000 times 0.03, 9,000 times 0.07, and that should give us a total of 810. So another good way to check an answer very quickly to make sure that you're right. Okay, so in this situation, we just graduated high school and received a large sum of money. You invest half of the money in a fund paying 11% annual interest, and you invest 1/8 of the money in a fund paying 9% annual interest. Your return on these investments after 1 year is $331.25. How much money did you receive for graduation? And try to avoid the whole concept of, well, I would just count it in the first place. Yeah, I get it. We're trying to work on a process of solving the problem. We're not working on necessarily the realistic logistics of it. So same type of setup. We have two percentages, 11%, 9%. Doesn't matter which one you pick as X. I always go with my first one. So say let X equal amount invested at 11%. I have a total. That's going to go to the right-hand side of my equation. 331.25. So again, same type of setup. I know that I have the money invested at 11%. So half of the money is invested at 11%. So we have 0.11x. By the way, there's no need for me to have that parentheses there. I'll set it up much like the last one. The second part, 1/8 of the money invested at 9%. I see my mistake here. X is actually not the amount invested 11%. It's the amount received for graduation. So I'm going to highlight that just because it was my mistake. I want to emphasize it. So X is going to be the amount received for graduation. We are adding those together because we get the interest from both accounts. Now, the one thing we have not taken into consideration, half and 1/8. So that has to be written down below too. So if I take half of the money and invest it at 11%, I am going to be multiplying this by 1/2. If we take 1/8 and invest it at the 9%, we multiply that by 1/8. So a couple things that I'm going to do here. First, I want to get rid of fractions. So multiplying by the LCD is probably what I want to do. So in this case, I'm going to multiply this by 8, multiply this by 8, multiply this by 8. That gets rid of all my fractions, and this becomes a 4 times 0.11x plus 1 times 0.09x equals 331.25 times 8 is going to give me 2650. And so multiplying everything by 8 gets rid of my fractions, less stuff to think about. Distributing that 4 through and that 1 through, if you need to do that, this becomes 0.44x plus 0.09x equals 2650. Combining like terms, that's 0.53x equals 2650. And dividing by 0.53, dividing by 0.53, x equals 5,000. And so looking at our initial question, we want to know how much money we received for graduation. Well, that's what we said our let statement was going to be. Remember, I changed that. I made my mistake initially. And so our x actually represents the answer to the question. And we received $5,000 for graduation. The moral of the story is when you graduate, invest the money.